All right, so this is going to be tutorial 2 on how to use DefinedMotion. And so just a quick overview. I did a more detailed description in the first video, but DefinedMotion is animation library that I have made for programmatic animations. And it's built on top of 3GS, so it gets all its features and ecosystem and stuff like that. And since the last video, I have done the commit to the GitHub, so it can now be used by doing this npx command to get the project and stuff like that. So in this tutorial, I'm gonna do this animation. So it's just an animated function surface that has some materials and with a moving camera to get into 3D and show a bit more of how a bit more advanced animations can be done. So I'm gonna start by creating a project for this. So from the terminal, I'm gonna use the command that the GitHub page tells me to now. And for the project name, we can call this the one I did before was YouTube EC1, so this is going to be YouTube EC2. And actually, I can copy this because we want to be in the documents, so documents, and then we do that. And we are going to get that set up. And so I'm going to start a VS Code window for that. So all right, so now you should see the project, and I can close this down because it was just for the preview. And when starting a new project with the CLI tool, we need to do npm install. And then we can do npm run dev to get the first view, and it will show what we did in the last tutorial. So this just circle going back and forth with the changing color. And so now we are gonna create a new scene for this tutorial. And so I will call this YouTube EC2, and we will make sure that the entry points to this. So yeah, we haven't exposed any function yet. So export function YouTube EC2, and as the last time, we should return an animated scene like that. And when we return that directly, so new animated scene. And for this one, I think we want it like it could be whatever, but I think we want it square, so we can say 1500 by 1500 in pixels. And then for the space, we want 3 dimensions this time. And the hot reload, I think we're actually going to go with begin from current to save computation on the hot reloads. And then lastly, we give the callback to create the entire scene. So something like that, and then we should be good to go, and we should make sure the entry points to this. So tutorial EC2, and no, actually we named it sorry, YouTube EC2. So we have this black view, which is expected. We haven't added anything to it. We can put it here so you can see as well. And so to make this video a bit easier and not too long and boring, I'm gonna copy parts from the actual tutorial, which can be seen in the repository. So the first thing that we want to do is that we have set up the scene, so that's good. And we have this function surface, and this function, the surface will have a material. So we're gonna add that, and it is just like a completely regular 3GS material. So we need to import the 3GS as well. So that will be inside here. So we have that material now, and it will be a mesh standard material with some metalness, roughness, and a white color, the FFFFF. And yeah, so the next thing we want to do is that we want to define a function that can help us draw this function surface. So this can be done in many ways. I mean, we're just building on top on 3GS, so it's up to us to decide. But I found this solution to be quite easy, and that is that we create a function that returns a function, and so our function returns a function that will from x and y coordinates produces a z coordinate, or a third coordinate, and the function that returns this function has a time parameter, since it should be animated by time. So it returns a function per frame that will be the current what do you say state of the animated surface. So we have that, and then we actually want to make use of that, and so we can add this, and I'm gonna explain the entire part. So first we need a domain, so like where should the how big should the surface be, like what should the limits be. And so we have xmin, xmax, ymin, ymax, and we have just put it to 7, but it can be whatever. Then we have a function that DefinedMotion exposes called create function surface. And if we look into that, we can see that it takes a function, so it's optimized or made for the format that it takes a function per frame, and takes x and y coordinates, but they're called a and b here, and returns a value for the z coordinate. And they have the minimaxes and the amount of segments, which also can be given if you want, but 200 is fine for us now. And it uses 3GS primitives to create this surface, so nothing special really, just a helper function that DefinedMotion exposes. And it builds the surface by using the plane geometry. And yeah, it fills it with the values here like a helper. So we use that, and we give it the domain. We set the surface material that we created earlier to the 3GS object that we have created. And lastly, we want to add the surface to the scene, and this should actually be named DM scene for DefinedMotion. I wrote it wrong, so that should work. And the naming of why I call it DM scene and not just scene is that the DM scene is the DefinedMotion scene, which has access to all the helper function and stuff like that. But the DefinedMotion scene also contains a 3GS scene, which is the actual scene that is rendered, but it doesn't have the animation primitives connected to it. So that's why I separate them in names, so I don't get scene.scene. Yeah, so next thing we're gonna do is that if we look at the tutorial here, we can see that we're gonna add a sphere later that will act like a light, but we can wait with that. And we're gonna need to set the camera position. And this is quite nice because when you do programmatic animation and you need to set a position for the camera, it can be quite tricky to get the coordinates right because you don't really have intuition for, you know, the size of the space and how what a good angle would be just in by looking at coordinates. So when moving the scene, I don't think it's movable even if it's completely black, but you can see that the or actually I am in the way. You can see that when moving the camera, the scene is just black, but it writes the position and rotation, which means that when you are building scenes, you can move the camera around for the position you want, and then just copy the position and rotation, so you don't have to guess in the code what those should be. So that was the method I used to get this, and they are fine, so I'm just gonna reuse them. So we set the camera like there, and the reason for why the name is off is because I called it just scene before. And then we can make use of the helper function from 3GS to make the camera look at the center or wherever we want, but in this case the center. So we add that as well, and we get that. Again, renaming the variable here. And then there are details here, but I just want to get the basics up. So we're going to add a weight to the animation to make it last, because in the previous tutorial I kind of made an animation from an interpolation, so it naturally had time. But here we just add stuff to the scene. We haven't added any like motion or animation or anything, so the animation has 0 time. And to just get us some frames, even if we don't apply any animation to anything, is to just add a weight, because yeah, then the scheduler will say that, oh, we will have things or the animation being the wait time, so the frames will, you know, tick, and in those frames we can apply the things that actually moves things. So I think everything will be set up now. The reason why it's completely black still is because we don't have any lighting, so the scene yeah, it doesn't have any light, so we can't see anything. And we could I think DefinedMotion also has like add scene lighting and then the scene, and here it wants the 3GS scene, so dm scene. So if we save that, we can see that now we actually see the function surface because there are actually lighting in the scene. And if we play this, we see nothing, which is to be expected because we haven't made the thing be updated with time. But we can still navigate this, and as you can see, we get the cool material because we're using 3GS and its rendering capabilities. So that's nice. And we're gonna add the animation of the function surface. So I will copy that. We can add it almost at the bottom and rename some things. We can actually begin. We begin without these. We will come to them later. But so now we'll import this one, update function surface. So this says that in the scene, for each tick, like for each frame, which we have many frames now because we added a wait, the function given here should be run. So this says that the time is the tick divided by 20. We can actually get the time here, but or the actual time, but this time is probably something that made the animation look fast enough, go in a good pace. So we call our function with this t that we calculated that represents time, and this was the function that we defined earlier, and it returns a function to us that is like the function that uses this time, and we call update function surface with the new function that we got for this time frame, and we also give it the surface that we want to update, so the geometry, and then also we use the same domain because it's the same. And so if we save this, it should animate if I click play now, which it does. So that's great. And we have some things we can do more to get it to look like the reference. And so the first thing is that in that we had like a rotation around the surface. And so that is done by having a variable called angle, and then we use that angle to make the camera move and change direction for each tick. So something like that. And then we want to increase the angle value for each tick inside the on each tick. So now we have made the camera like move in a circle around the scene, and while it moves, we make sure that it always looks at the center by doing this look at, and looking at look at, which was the centrum of the scene, the 0, 0, 0 coordinate. And yeah, that should be fine to see our rotation. And yeah, so we see the rotation. One thing that we also saw is the like wobble that was in the example. So it's this that makes the camera go zoom in, zoom out, or fly in, fly out during the rotation. So if we remove that just for the sake of looking at it without it, then we should have this pure rotation around. And so that's nice, and we can add the wobble back. And what we can do next is that in the reference we had like a white sphere around or above the surface that was shining light to get lighting effects and stuff like that. So that was made by having this. So I can explain. I should just copy it over and we can put it like, yeah, anywhere but here. And then we also need the material for the sphere, which we can add to the top together, at the top together with the surface material. So now we have that, and that was made by, we create a sphere, just a regular 3GS sphere. So we used the primitives that 3GS gives us. And then we also create a point light, because the sphere is what is like the object that can be seen, the lamp, but what's actually doing the lighting, shining the light, is the point light, which is like a separate thing in 3GS. So we add them both and we make them to the same position, which we do here. We copy the position. Again, we're using a nice function that 3GS gives us. And then we create a group that we add them both to. So by having this group, it's quite nice because we can handle, or we can set update the position only one time instead of both, and we can be confident that they will move together. And we set the Y position to 6 to be a bit above the plane or the surface. And then we add the group to the scene so it can actually be seen. And yeah, that is probably it. So if I run this, you see this quite nice reflections and these nice reflections and the material and movement. And I can still navigate this scene however I want. So I think the reference had like a background gradient in blue. So I'm gonna add that as well. And I can add it like maybe just at the start. And so that uses a function that is a helper to create a gradient to our scene. Is it the 3GS scene? All right, it was I need to actually name the field, of course. So I didn't have to do that when they were the same name. So now we have the gradient, and it also gives some kind of additional color to the material. And now we are there, I think, completely. The only difference is that we added this lighting just to see the plane from the beginning. So if we remove that, we have the exact thing, but I actually think it looks cooler with the lighting, so I'm gonna keep that. It gives a bit more nice reflections on the surface. So yeah, I think that was it, and it gave like, yeah, some insight of how we build like a basic 3D scene with a function surface and some materials. So yeah, thank you for watching, and hope you liked the tutorial.